So yes, welcome to Solid State Logic, and welcome all of those who are viewing online. Yeah, it's quite interesting me being in front of some AES members and talking about analogue electronics, because that was a speech or a discussion that I had many, many years ago. I think probably 20 odd years ago. I did a talk to the AES members about what at the time was our developments for analogue technology, and the title of that speech was all about a sort of a common. I mean, I've worked at SSL for 37 odd years now, and when I arrived at SSL as a sort of service engineer going out to service and install analogue mixing consoles, a big discussion at the time was, you know, how long is it going to be when we're going to stop making analogue mixing consoles? And it was kind of like, well, maybe in 5 years' time we won't be making analogue mixing consoles. And as I said, that conversation was something that I was having 37 years ago. That was something I did probably 20 years ago as a presentation to the AES, and here I am, God knows how many years later, discussing analogue technology and an analogue mixing console. So yeah, so that's in some ways some of the context to what we're going to talk about. But I'd just like to give you a bit of background to some of the things that we're talking about. So yes, the person in the middle of this picture, some of you may recognise, some of you may not. It's Colin Sanders, who is the person who basically started Solid State Logic. And in '85, so nearly 40 years ago now, Colin and a bunch of the other engineers at SSL had got together and basically wrote what was quite an interesting book, basically. And the book looked to what the future of audio mixing console technology might look like in 10 years' time. That was their 10-year outlook. And the three sort of technologies that they considered were analog technology, digital technology, and digitally controlled analog technology. And the book sort of considered, or the book is maybe a slightly stronger word because it was about 50 pages or something like that, but it considered the benefits and the challenges of each of those three technologies. And it sort of basically said, well, analog consoles are challenged by their physical size. So their physical size is directly related to their channel count. So if you have a 12-channel console, it's kind of this big. If you have a 96-channel console, it probably stretches nearly the width of this room, because every channel and its electronics live underneath the channel that's in the channel strip. At the time, we were also, sorry, I was meant to do that. So at the time, we were also at the sort of embryonic stages of digital mixing consoles. And one of the great benefits of digital technology is basically their huge flexibility. You can control a lot of channels from a very small space, and to a certain extent in '85 they probably weren't really predicting the rise of something like a workstation, where in this particular room we're playing back audio from a laptop that's handling, I don't know, in this case probably about 30 channels of audio, but it could quite easily do 96 channels of audio. So there in some ways is a sort of classic example of digital technology being able to replay massive amounts of channels with a very small footprint. But there are technical challenges with digital audio, especially when they're interfacing and involved in a world that has some analog elements in it. Our ears are analog, quite a lot of musical sources are analog, and there is still a lot of analog processing technology that lives in the world. So although we might have thought we would see the last of digital compressors, of analog compressors and analog EQs, they're still made in their thousands and are a popular part of certainly music production these days. So yeah, digital technology has its challenges in terms of latency, sample rate, clocking, and when you're interfacing to analog, you need to sort of consider some of those things. So the other sort of technology that was analysed in this book was digitally controlled analog, and it was kind of inferred that might be an ideal balance of easy interfacing to analog, because there's no issues of sample rates and technical conversion issues, but the ability to totally recall and reset everything. And so in some ways it was an ideal balance. However, in those days, in '85, there were some significant technical issues that would come along with digitally controlled analog. speed of processing, resolution of control, and in this book's analysis and in the analysis of that time, it was like, maybe this isn't commercially feasible yet. So although it's an ideal solution to balance these two technologies, we're not ready for it yet. I mean, and some irony, about 3 years after that book was published and that an announcement was made, Euphonics came along with a digitally controlled analog mixing console. However, it was expensive. You still needed a separate machine room to house all of the racks. In terms of the channel count versus the amount of rack space you needed, it was a pretty significant piece of technology. So that was 30, 40 years ago. But today, SSL has spent quite a long time researching and developing technology to balance those two things. We still make big analog mixing consoles, but in the interim period, we've had and introduced a range of products that are kind of intermediary products, if you like. So they're not a console that you'll find in a massive control room. They're project-related analog pieces of equipment, and this is a classic example of that is a product that we've made now for 22 years called the AWS, which stood at the time for Analog Workstation System. And the concept behind that product was that basically it would put everything around a digital audio workstation that you needed to make a session run or do a production. And so in terms of, and that product's been really successful for us. We've sold a lot of them into what are now fairly commonplace things, but at the time were embryonic, which are sort of home user owner. So they're not, they're professional production teams, so professional producers, professional engineers, in some cases musicians, and also a lot of educational facilities who want to build sort of workshop rooms in fairly smaller spaces. So we went from a market where that product and that market was sort of embryonic to a market where it's now fairly commonplace. It's been a successful part of SSL's business. But as is reflected in the book that we were mentioning earlier, the challenge of analog technology is its scale and its size and its ability to change projects instantly, which the more workstations became part of people's workflow, the more pressure there is to be able to do that. And hence, that's basically where it was the impetus and the background to us working hard on introducing the Oracle console that we're in front of today. So yeah, I mean, it's quite ironic that one of the features that people liked about the early SSL analog consoles was a feature that we made and would sell to people quite strongly, which was total recall. And in those days, total recall was basically the ability for the console to remember the positions of the controls. But in terms of resetting those controls, that was a very manual process. But nevertheless, that was fairly revolutionary at the time. But it's quite fitting in some ways that Oracle kind of brings that reality of total recall now to studios and studio production. So yeah, I mean, Oracle, a few things about Oracle. It's designed with a fairly familiar console layout. And it has an inline architecture. This is one of the things that we've kind of learned as the evolution of our earlier sort of project analog consoles. There was a point at which we thought that maybe there was the need for a tracking path, which was one path through the analog domain. Once it was in the digital domain, you'd then basically be mixing it in the workstation. What's been interesting is that in that journey of workstations and workflows around workstations, the concept of summing things in analog and therefore having not only an analog record path but also an analog summing sort of, monitoring path has retained a fairly strong requirement, and that's really why when you look at Origin, which was a console that we introduced a few years ago, which kind of looked back to those early SSL analog inline console days, that's kind of why Origin is an inline structure, and indeed Oracle has similar inline structure in that it has a channel path that has a record path and a monitor path as kind of independent elements. And there are some significant benefits to that in terms of the amount of bang for buck you get from the processing in the system. So one of the things that we sort of summarised Oracle about was that it sounds and feels like an analog SSL console, but now with truly total recall and instant reset. So in a nutshell, just to sort of to give us some headline points to start off with, Oracle can kind of be summarised as it's a new analog console from SSL. We use a technology that we've given the buzzword active analog to allow session recall in an instant. It's got a discrete control surface, so basically you could reach out and grab things like equalizers and frequencies and that sort of thing. So it feels and looks fairly analog. Because it's analog, you don't have any issues with latency, and you can do parallel mixes, and you don't have to worry about phasing of those two mix sources and that sort of thing. It's got a pretty flexible architecture, so harking back to that inline structure where there are ways that you can use inline for recording, so you can record paths and monitor paths. You can use them for overdubbing, so that you can create a mix and just add in whatever the additional track that you're trying to replace or trying to overdub on that original track. And similarly, mixing. With mixing, you can use both the channel path and the monitor path as inputs to your mix. And in the case of Oracle, you have a level control and a pan control for each of those paths, and you have an insert point and you have a direct output as well, because one of the modern ways of working with a workstation is you'll set up a mix and then you literally will just print that mix to additional tracks on the workstation as kind of stem mixes, basically. The workstation control is also an inherent part of the way that the console works. So you can control analog levels, you can press a button and you can now control the actual faders that there are in the workstation as well. And there's an application that runs offline as well, so you can prepare sessions before you actually even come to the studio, which is useful. And the footprint makes it basically almost a centimetre for centimetre replacement for those small AWS consoles that we already have sold many of. And yeah, one of the big sort of discussion points at the moment is immersive audio and surround production. And one of the benefits of a completely digitally controlled analog system is that, as standard, Oracle's monitoring system is controlling stereo mixes and stereo monitor outputs that are in the frame. But it's doing that by sending control signals from the control surface to the racks. That technology can equally be diverted to something like a renderer, an immersive renderer, so you can control the monitoring for an immersive renderer from the same control surface. So it has the ability to sort of work in those workspaces and in those functions as well. So yeah, I'm just going to talk a little bit about the sort of physical nature of the console. So fundamentally, it's a control surface that's made in 8 channel wide bays, which, if anybody has long memories for SSL's 4,000 consoles and our 9,000 consoles, that's traditionally how SSL made its mixing consoles. And then we get into the balance of controls versus size of frame, basically. But fundamentally, from an operational perspective, it's fairly straightforward. There's an input gain control at the top of the channel strip. There's a filter control with flexible variable filter settings at there's the next point. We then control for aux buses, and there's switchable control for gain, pan, on and off for those auxes. Then there's a sort of 4-band parametric equalizer. This is kind of a classic SSL signature part of pretty much every console that we've ever made. So sort of a shelving or bell characteristic for the high band, for the HF and the LF sections, and then fully parametric mid bands, and the ability to switch the characteristic of those mid bands as well. The original E-series consoles had a sort of variable Q with gain. When we introduced G, we introduced basically a constant Q with gain, EQ, and our EQ characteristic in the control surface is the ability to do those two things. And reassuringly, when you switch between those two characteristics, you get a nice click as it switches to the electronics. So you can, it's reassuringly analog, even though it looks very digital. So in terms of sort of the signal flow through a channel strip, it's a pretty standard thing, and is fairly recognisable. Below the channel strip there are 8 faders, and those faders, as you might expect, give you level control and pan control, there's a solo key and a cut key, so it's all pretty easy to use in terms of someone who's familiar with an analog mixing console. Pretty much they can walk up and at least recognise and be have familiar controls in front of them. Then you get to the sort of periphery of the channel strip, because what you would have noticed is that those 8 channels are surrounded by sort of knobs and switches. And those basically are placed to the left and right, and that's where we gain the benefit of digital control to reduce the size of the footprint of the control surface that we actually have in front of us. So fundamentally, we provide, there's controls for display selection, controls for routing, controls for which set of the channels that you've got in front of you, controls that allow you to link various bits of processing together, navigation controls that you can use for some special functions that I'll come onto a little bit later. But basically the idea is that to the left and the right are the things that are kind of more set up functions, whereas the things that you're using all the time are kind of in front of you all the time. The console has got each bay of the console has got its own meter bridge display, and at the top of the meter display you can see the bus routing, and the meter display can also be switched between 2 different characteristics. So we can have a VU meter or we can have a bar graph meter. In the very early days of SSL console, this was kind of a cost option. As standard, you had a console with VU meters, mechanical VU meters, and you could also specify bar graph or peak program meters as an option. And in some ways harking back to that, and in some ways to meet the challenge of how do you make something that is inherently digital feel a bit more analog, then we provide kind of both of those metering solutions in the same system. As I said kind of earlier, it's designed to have an inline architecture, and so if we have a quick look at the signal flow, then it really is 2 independent paths with, as is common with many SSL consoles, a sharing of processing between those 2 paths. So traditional inline design, the filters can be moved between either the large fader path or small fader path or channel path, monitor path, however you want to describe those things. And there's in terms of fitting into more modern workflows, there's also an insert point in each of those paths. So where you've got someone who's got a lot of analog compressors, might be a classic thing. Sort of vintage compressors and analog compressors are made in all kinds of flavors in terms of FET compressors, VCA-based optical compressors. So there tend to be a bit of a proliferation of those sort of pieces in typical studios, and an insert point in each path. If you're using the console to mix, so you're using both the large fader path and the small fader path as inputs into your mixes, then this allows you to put sort of boutique processing in both of those paths. And the insert point is also movable, so you can move, if you're using the internal EQs, for example, you can move and swap around the order of the insert point and the EQ. And if you've got a compressor in your insert point, so that's basically comparing whether your compressor's before your equalization or your compressor's after your equalization, which are the classic kind of things that you want to A/B. And indeed, one of the philosophies of the console design is that where there's a situation where you want to A/B 2 things, there's a switch under your fingers that will allow you to do that. Which is another sort of benefit of an analog system that you would expect from an analog mixing console, that isn't necessarily something you find in digital systems. So again, going back to that point about printing mixes back to the workstation, there's a direct output in both of those paths as well. So in a case where you're using those 2 paths to create your mix, you can print both of those paths independently as well. And this is all about basically using the capacity of a workstation to have hundreds of tracks and basically printing the stem. So when you want to remix something, you can recall, you just put the faders at unity gain and bring it back, and you're getting all of that back from the system. It's interesting in the context of a console that can also instantly reset and recall all of its configuration capabilities as well. And then sort of the final piece of interesting things is we're using digitally controlled analog circuits. And so this allows us to basically link odd and even channels to create stereo channels as well. So the sort of the classic, so in fact going right back to the early days of the 4000 as well, we would make a stereo channel which would be used for stereo effects inputs or for stereo returns from tape machines or synthesizers or other stereo sources. You had to specify those in a bucket, so it was a choice that you made at the specification stage, whereas here we are today, you can basically press a button and configure that as you wish in the system. The bus architecture is another, and in some ways this is one of the things that's quite a significant evolution from the AWS console that I talked about earlier, in that the bus architecture of the console has got 34 mix buses in total, and any channel can access those. And one of the interesting things about the way the console is designed, and this is inherited from our larger console called Duality, where basically you can see all of the buses that are going out of the console on a single screen, and you can see them all of the time. So this allows, the situation where you're sending a phone next to someone in a studio floor and they're listening to, and they're sort of saying, well, I can't actually hear anything. You can look at this screen and say, oh, actually, there's nothing coming out of aux 3 and 4, so I need to go make sure that I'm sending something to you. So being able to sort of see all of the bus outputs is quite a useful feature. And as I said, there are sort of 34 of those buses, and they're kind of split up as follows. There are 4 main stereo mix buses. There are 10 sort of what I call flex aux buses. So classically, another thing that an analog console would have is it would have Q sends, or it would have aux or FX sends. And the Q sends would be typically stereo, the FX sends would be typically mono. Well, here we've got 10 mix buses, and you can basically assign them to be stereo or mono as you wish. So depending on what sort of how many stereo feeds you might need to send, you can configure anything from 1 stereo mix bus to 5 stereo mix aux buses. There are 16 track buses, and the track buses again get used to create submixes, or they can just be used to route out of the system. So in the old days, you would use a track bus to feed a multi-track tape recorder. These days, quite a lot of tracking is done with direct outputs to feed into the workstation, and you might use the track buses to do some submixing, but they're used for a lot of things, and so you can use them for both those purposes in this console. And then, as you might expect, there are AFL and PFL buses for soloing and listening to things. Going back to the track buses, one of the other things that the track buses can do is they can feed 8 stereo groups. So in the sort of center section, which is basically on the right hand side of the surface that we're in front of here, there are 8 stereo group inputs, and those are quite interesting because they can pick up the track buses in pairs, so you can use them as an audio subgroup, and or you can just feed stereo returns into them, so that might be effects or that sort of thing. And basically what that means is that you can use them sort of flexibly as returns, or you can use them as extra inputs to the mix. Those group inputs can also route to the mix buses as well as to the aux buses and the track buses, so they truly are usable for a lot of flexibility. One other interesting thing is that they've got a width control, so you can come in as sort of left-right. You can mono that left-right down to mono. You can do the classic things as mono from left, mono from right, mono from left and right. The other really interesting thing is because there's some sort of phase management circuitry in there, analog phase management circuitry in there, which basically allows you also to configure a left-right input into mid-side. So in the inputs, in the input of the image control, you can say, okay, let me turn this into a mid-side signal. There's an insert point in those group inputs as well, so you can process independently and insert the mid and the side signals, so you could compress the mid signal independently of something you were doing for the side signal. And then, of course, on the insert return, there's an MS decode circuit that you can switch in, which basically will then turn that back into left-right. So it's quite a powerful powerful input, a group input, powerful part of the circuit. So, 4 main stereo buses. I won't dwell too much on the detail in here, there's quite a lot of detail to go into, but fundamentally you've got 4 main stereo buses, and the primary bus, so mixed bus A, has bus processing in it as well. One of the classic features of all SSL analog consoles is that their main mixed bus has got a bus compressor, and Oracle wouldn't be an SSL analog console without one of those, so it has that. And each of those main buses also have their own insert points as well. So there's an awful lot that you could do with those mixed buses. Control room monitoring, again, a mixing console is designed to live in a control room, and control of and listening to various different speaker sets is all part of that functionality. And so yeah, SSL has got the Oracle supports up to 5 control room monitors, and there are also 3 independent flowback feeds. So in a situation where you're working with the studio floor and you're sending signals out to the studio floor, you've got flowback feeds that can feed from the auxiliary buses and then add in talkback, so you can talk individually to those 3 outputs, or you can link the talkback controls together. And the other feature that SSL consoles classically have is a thing called a listen mic, which is basically a microphone that's designed to live in the studio floor, and SSL classically has got a huge compressor that's attached to that listen mic, so that basically anybody in the recording area can make a noise, you in the control room can hear it, and this wouldn't be an SSL console without a listen mic compressor in it. So it has that capability as well as having the similar capability on the talkback. And in common with more modern SSL consoles, in the original 4000, that was sort of hidden within the system as part of the system architecture, because who would ever want to record that nasty sounding compressor? And of course, these days it's a standard part of the structure of SSL consoles that compressor, you wire the input and you wire the output to the patch bay, so that you can actually record that really horrible, nasty compressor. Your Patrick's got a lot to answer for. So yeah, control room monitoring, and as I said earlier, one of the other features of the control room monitoring system is the ability to hand over its control protocols to work with. Typically OSC is one of the sort of common immersive control protocols to control an immersive renderer. And one of the things about those renderers is that they not only do they do the sort of immersive encoding, they also do speaker EQ, so they do quite a lot in terms of the monitoring, which if you were trying to do that in analog, you'd probably have another rack the size of the racks that we've got to do that. So our immersive control is something we hand over by just changing the control protocol that we're sending from the control surface. So yeah, I've sort of mentioned the fallback feeds and the talkback. So I'm going to talk a little bit more about the center section. So fundamentally, there's a sort of set of controls in the console that allow you to control all of these things and typically control what's going on in the workstation. So you've got a large set of transport controls, and there are 4 stereo alternate speaker selections that you can select on the press of a button. A large monitor level control, and that monitor level control is always a monitor level control. So if there's noise in the room and you need to make it quiet, you just grab that big knob and turn it down, and it goes quiet, and everything's all good. A large fader for the main mix bus levels, independent talkback switches, as I kind of mentioned, and then a space. It's interesting. There's a blank space in this center section as well, and that's because quite a lot of modern workflows with workstations include using things like a tablet or a thing called a stream deck to make programmable function keys for how people are driving their workstation. And by leaving some space for that in the control surface, you make lives just a bit easier for everybody, really. So yeah, I've been through these just to summarise things. Oh yeah, one other thing that I didn't mention is that, as I mentioned when I was talking about the main bus, is about the bus compressor. And indeed, the console has got a sort of set of bus compressor control keys. So even though we're digitally controlling analog processing, we've kind of laid those bus compressor control keys in a very familiar layout that would be familiar to anyone who's ever sort of sat down and used our bus compressors. Okay, so enough talking about the sort of the gazinters and gazouters and the processing. A quick talk about system structure. So, I mean, what we're stood in front of here is pretty much the picture that we've got in front of us on the presentation. So this is a kind of typical Oracle system. The control surface is the large thing with knobs and faders that we're in front of here. The analog processing, so where the analog signals actually are in the racks that are to the left. There's images of the racks in the presentation, but for a 24, so basically there's a rack that does the center section processing, and that's all the busing, all of the monitor switching, the stereo inputs, the stuff that, everything that isn't in the channel strips basically. And then there's a separate channel processing rack. And one channel processing rack carries up to 24 inline channels. And you can add a second processing rack to increase that to 48. And that's another benefit of digitally controlled analog systems in terms of scalability, is that traditionally if you wanted to go from a 24 channel analog console to a 48 analog console, you needed to knock about 3 foot out the side of your room to get the console in. Well, now we can actually just add another additional rack, and you can do that. There's some other little design features about the racks, which has all come about really since in the early days of analog mixing consoles, where you had a lot of power supplies and you basically had to have a machine room to accommodate all of that stuff. When project studios came along, it was like, well, actually, we're trying to get all of this into a garage space or a barn space, or and so the requirement for power supplies was, well, actually, it's all got to live in the same room, basically. And certainly with older processing technologies that generated a lot of heat and therefore needed a lot of cooling and a lot of power, the concept of having that in the same room as the control surface was never going to fly. And that was one of our challenges, basically. And the other thing about an analog mixing console is that if you think about where the analog signals are wired to, because the analog electronics is in the console itself, all of the analog ins and outs come to the control surface. So your wiring of your studio is all wired to the control surface. And that's true of AWS as well as many other consoles. So if you're going to replace that with another console, the processing technology, in the case of digitally controlled analog, needs to live and be able to live in the same footprint of space. It needs to not generate enough heat, and more importantly, not noise, that you can't have it in the same room as the console control surface. And that was one of the significant design challenges in developing Oracle, was trying to meet those parameters. And although the racks that we have here are put in these flight cases with patch bays above them, those of you with tape measures would measure that basically if you measured the height of those racks, and if you look at the depth of this control surface, you'll find that those racks will actually fit just under this control surface, with a cooling requirement that comes in through the front and is exhausted by just basically putting the rear of the rack just behind the control surface and it vents out the back. But equally, low power consumption is another sort of requirement that comes along with this. And those of you who are in the room, if you can hear something, my guess is it's almost certainly the H&H power amp that's behind powering these speakers. It's not the racks that are associated with the console. So a huge part of our design challenge in putting this system together was meeting some of those requirements. So yeah, as I say, sort of, and the typical system is a control surface, which is this sort of shallow thing, which is capable of table mounting if you wanted to, as well as living on its own legs, and a rack and a pair of racks that you see here. So one other piece of the puzzle that is interesting to think about is, and I reflect on this because of the early ways that the 4000 console worked. So the 4000 console was one of the first consoles that tried to integrate computers with audio or with analog mixing. And it was quite clever in some ways, very clever in many ways really, but one aspect of the way that the computer and the console worked together was that the computer had its software running on one disk, so it had a thing called a program disk, which you plug into one drive, but the session information was on another disk, which was the real disk, which you plug in independently. And the huge benefit of that approach was, at the end of the session, you, as an engineer or a producer, you would take that real disk, you'd put it with your multi-track tape, and you walk away, and that console had no memory of that session happening at all. And the huge benefit of that in a room where you're changing sessions all the time is that you're not leaving a footprint behind of what you were doing, what sessions that were in, what artists were in. And as computers got more integrated with mixing consoles, they started to have operating systems inside them that stored that information, and you could copy that information off of a separate drive. But you had to remember, or somebody had to remember to erase that to stop, to not leave that footprint behind. And that's one of the things that we kind of reflected on, partly from a functional perspective, but also because these days laptops are powerful enough to run workstation sessions and drive I/O independently. So you don't need to transfer data to a certain extent. If your laptop can be the source of storing and replaying and recording that information. So what we've designed is basically a sort of a management application that also can live on that laptop. So you again can take it away with you. So that's a thing that we call O-Control, and basically it's a sort of suite of apps that will run in Windows or in Mac OS, and it can work in conjunction with the console, and it can work offline from the console as well. So it's perfectly feasible for you to run O-Control up. As part of running O-Control up, it says, I can't find a control surface to connect to. And you say, that's fine, just run locally. And so you can run locally, you could load a project that you've been working on, you could rename various aspects of that. So you can do some sort of preparation work. And then when you come to the studio, you say, the system says, I can find a console now. You say, okay, well, let me connect to that console. When you do that, the person in the console has to say, yes, let me connect to this. So in a situation where you've got multiple rooms and multiple control surfaces, you can't just walk in with a computer and take over somebody else's session. But that means that basically that O-Control app is the thing that keeps your session information with your workstation information and can move around. And as I say, it doesn't leave a footprint in the console when you go to work in another studio. So I've waffled on for a while now. So I thought I'd just show you very briefly I'll just play some music through the console. And what I'm going to do is I'm going to switch between a few sessions so that you can just basically get a feel for how quickly that can happen and the kind of processes involved in it. And in some ways, in a digital world, it's something you're very familiar with, but in an analog world, it's quite a new thing to be able to do. So one of the things that is interesting from Oracle is in terms of sort of tracking capabilities, the ability to have the separate monitor paths and the ability to create cue mixes and effects mixes is really powerful. The real killer thing is that you can do all of that with no latency whatsoever. So someone who is, one of our sort of stories is when Peter Gabriel bought the company and started to do live production. He basically, Manu Katché, who was his drummer, was really sensitive to delay. And one of the things he stipulated as part of our live technology was that we needed to be able to make sure that it didn't have any issues with latency for foldback. And so we ran the system at 96 kilohertz, we ran it on MADI at double frequencies, so as much as we could take latency out of the digital system. The real answer though is that actually if it was an analog mix, you just wouldn't have that issue at all. I'm just going to play some music now just to give you some, just let you hear the console a little bit. So one of the things that's quite interesting about the console is it basically behaves like an analog console, as you kind of expect. So if I come up here and solo a channel, I'm just soloing the channel as you'd expect to solo a channel. If I put an EQ in here, and basically if I sweep that EQ, so I'm narrowing the Q on this now. So it behaves like an analog EQ, like you'd expect an analog EQ. And why wouldn't it? And the reality is that the technology to make that work is pretty significant, really, because what's happening is I'm sending parameters to the workstation, to the computer here. That is turning that into commands that it's sending to an analog card. That analog card is sending it into processing that it then has to manage to change. And basically the way that it works is that many thousands of times a second, and with a resolution of 16,000 steps, it does all of that so that the end result for the user is they can sit there and play with the cue and the frequency, and they don't know that that's happening. Basically, it feels like an analog console. It's interesting to reflect on the amount of technology that it takes to do that. So I'm doing my tracking session. I get a call to say, oh, actually, somebody wants to come in and revise something that they were working on 5 minutes ago. Are you able to get back to where you were with that other session? So basically, I can do that. So I'll come over to here to my Pro Tools. I basically say, okay, well, let me call up another session. So I'm not going to save those changes, and I'm going to come over here and basically open a new project on my O control. So yeah. It changes and resets everything in the control surface. When it does that, the other thing that it does is that it turns the monitor level down. So it's kind of just as a safety thing, just in case somebody's left their Marshall on 100 or something like that. And now I'm working on a completely different song, completely different session. Instrumentation has changed, the whole layout of the control surface has changed. And again, like switching cues in and out of circuit, completely different mix, completely different session. And just in case that wasn't enough proof, I'll go now and say, okay, well now somebody's called up and they want to just do a quick mix session or a quick remix or something that they did. Do the same thing again. I come over here, I say, okay, let me load up a different Pro Tools session. I'll come up, load my Pro control session, reconfigure the console. Press play. No, Pro Tools wants me to not save that. Press play. Never been much for romance. See different wasted too much time. Different configuration. Then I saw. So everything about the console has changed in those changeovers. So in terms of sort of the universal use of the tool, it makes it easy for a studio to say, well, you know, give me an hour and I'll completely do another revision of that mix, and then we can come back to that tracking session. So, and that's the sort of the benefits that you'd hope that this would deliver. And we'd like to think it does. So the sort of that, and that's to a certain extent why we describe this as kind of future analog. Really, is that it's doing things with analog technology that hopefully is not able to do before, and you don't need to worry about any digital issues in terms of sample frequencies and clipping. So yeah, a more sort of smooth production process that you'd hope something like this would be. So that's. I'm just going to talk briefly about summarising what I sort of said earlier. Really, so Oracle's a new large format console from us. It uses active analog technology to deliver this instant session recall capability. We hope that the discrete control surface makes it easy for people who are familiar with analog consoles to use it and not feel kind of basically get their sessions done quickly. Because it's analog, we don't have any issues with latency. Integrated workstation controls means that working with a workstation or working in a console is easy to do. And the ability to have various configurable paths and our inline structure gives us a lot of flexibility for our different applications of the console. And the ability to do offline preparation means things that move really quickly as well. And its footprint basically allows it to fit into fairly small spaces, either existing spaces or indeed new studios. And then sort of finally, monitoring capabilities giving us stereo operation and immersive capabilities mean that it allows us to sort of work with formats as they evolve in the future. So there we go. That's sort of pretty much my introduction to Oracle for you.